Natural physics is a concept I developed that explains in down-to-earth scenarios how the principles of physics could have come about from observing nature. Each episode begins with a scenario followed by an example to illustrate the application of these principles in futuristic research at the frontiers of science, such as my astrophysics research, and then concludes with an exploration of how these same principles could have very well been used by ancient cultures and civilizations. Mathematics is naturally encountered and incorporated as the exciting and fun tool of science that it is. Science is the window into our amazing world of nature, and mathematics is the tool to open that window. Natural physics encompasses current, futuristic, and ancient physics, and ties them together by the principles of physics that are common threads running throughout each. Greetings, I'm Leroy Larry, and welcome to our Natural Physics Variety Show, live from Costa Rica. Okay, the current solar storm will not destroy the Earth. However, it is the third most powerful solar storm in recorded history. The most powerful was in 1859, and the next most powerful was in 2003. Two amazing phenomena of nature are involved: the solar flares and the coronal mass ejections, also called CMEs. Very interestingly, they are similar to gamma rays and cosmic rays. The light from solar flares travels at the speed of light, as do gamma rays. Coronal mass ejections consist of protons, as do cosmic rays. Very luckily for us life forms on Earth, we are protected by nature.
A new image from NASA's Fermi Space Telescope shows gamma rays, the highest energy form of light, filling faraway bubbles of hot gas created by massive stars. The bubbles are located about 4,500 light years away in a star-forming region of the constellation Cygnus, the Swan, also dubbed Cygnus X. The outflow from Cygnus X's gigantic stars also creates intense magnetic fields within the bubbles, and it is these magnetic fields that help spawn the gamma rays by trapping and deflecting fast-moving particles called cosmic rays. Cosmic rays are tiny electrically charged particles that move at nearly the speed of light. They are primarily protons, and most were probably accelerated to their incredible speeds by star explosions known as supernovas. When cosmic rays collide with interstellar gas, or photons of starlight, they give off gamma rays. Here on Earth, we have particle accelerators that can produce high-energy protons. The largest in the United States is the Fermilab Tevatron, with a circumference of 6.86 kilometers, capable of producing protons with energies of 1 trillion electron volts, TeV. The largest in the world is the CERN Large Hadron Collider, LHC, with a circumference of 27 kilometers, capable of producing protons with energies of 13 trillion electron volts. However, cosmic ray protons reach us with energies thousands of times greater. The solar wind streams off of the sun in all directions at speeds of about 400 kilometers per second. The source of the solar wind is the sun's hot corona. The temperature of the corona is so high that the sun's gravity cannot hold on to it. This image, dated September 18, 2003, is from the SOHO Extreme Ultraviolet Imaging Telescope. The sun's atmosphere is threaded with magnetic fields, indicated by the yellow lines. Areas with closed magnetic fields give rise to slow, dense solar wind, indicated by the short, dashed red arrows, while areas with open magnetic fields, so-called coronal holes, yield fast, less dense solar wind streams, indicated by the longer, solid red arrows. In addition to the permanent coronal holes at the sun's poles, coronal holes can sometimes occur closer to the sun's equator, as shown here just right of center. The solar wind is a stream of charged particles released from the upper atmosphere of the sun. This plasma consists of mostly electrons, protons, and alpha particles with energies usually between 1.5 and 10,000 electron volts, keV. Embedded in the solar wind plasma is the interplanetary magnetic field. The solar wind varies in density, temperature, and speed over time and over solar longitude. Its particles can escape the sun's gravity because of their high energy from the high temperature of the corona and magnetic, electrical, and electromagnetic phenomena in it. The solar winds flow outward supersonically at varying speeds depending on their origin, reaching up to around 2 million kilometers per hour to great distances, filling a region known as the heliosphere, an enormous bubble-like volume surrounded by the interstellar medium. Streaming out of our nearest star at speeds of 400 to 760 kilometers per second, the solar wind strips planets with no magnetic fields and shapes the magnetosphere of those that do. In the case of the Earth, these highly charged particles are deflected by the Lorentz force and shaped into a long comet-like tail whose boundary is called the magnetopause. Geomagnetic storms can affect power grids, reroute high-latitude air flights, cause errors of up to 46 meters in global positioning systems, interfere with satellite communications, and endanger space missions and their crews. This is the Northern Lights, or Aurora Borealis. The aurora is caused by particles from the sun, the solar wind, which are trapped in the magnetic field of the Earth and then into the atmosphere, causing light.
The storm is going on as we speak. Check it out. There's a lot of information out there. And tune in for our next show. Same fat time, same fat channel.